So I'm going to go through the question part B, and we are given an expression for the pressure from the growing helium core, which is P0 equals this whole term, and we're asked to show that the maximum pressure for which the helium core remains stable can be given by the following scaling relationship: P0m proportional to T center to the power 4 over mass of the core to the power of 2. Now, it's the maximum pressure. We've got an expression for the entire pressure, so all we need to do is find the extreme value for this equation. So P0 is where we're looking for the derivative being 0 with respect to the variable here is the radius of the core. So partial derivative of this with respect to the radius of the core and set that to 0 will give us an extreme value, and if you want to, but it's not required here, you could discuss why this then is a maximum rather than a minimum, but in usual case it's sufficient enough to show that this is an extreme value. So when's that equal to 0? So we need to do the derivatives of this whole expression. Okay, bear in mind K, M, T, both K1s and K2s are constants. So we can now do the derivative, which is going to be okay, so when is that equals to 0? So we can see we've got terms of r to the power 4 here in both, so I can happily times all of that by c to the power 4, and I'll remain with something. What I'm going to do as well, simplify my constants. I'm going to just call all of this first part K3, all of this part K4, again some random new constants that we pop in there, and if you multiply this in here, we are left with K3 and actually it would make life easier if I multiply straight away with to the power of 5, so we're left with RC here and no RC here, so we're not working with any fractions, equals 0, and I can now rearrange this to a scaling relationship. So first I can happily bring this over to one side and isolate the RC, so that's going to give me K4 MC squared over all of this side K3 MC TC. Now you can see you can already remove one of the mass terms in here, and if you're expressing this as a scaling relationship purely, you can just write this as RC proportional to MC over TC, because all of this part is just going to be a constant. So radius of the core is proportional to mass of the core over temperature of the core, which is nearly what we want to determine, because we are not asked about the radius, we're asked about the pressure. So we've determined at which radius the maximum occurs. Now we need to insert this value into the expression for the pressure. So P0 maximum, if we insert RC maximum, is therefore going to give us K1 MC TC. All of this we can straight away do as a scaling relationship, so I might write that out straight away as MC TC over MC power 4 TC power of 4. This is the R to the power of 4 plus MC squared, and then we've got at this point RC to the power of 5, so that's going to give us MC to the power of 5 and TC to the power of 5 here. Bear in mind I've ditched all the constants because we're talking about scaling relations. And what you can now see is that in our context we now have some simplifications we can do. MC goes away to the power of 3, here also to the power of 3. This part all is TC to the power of 5, and this entire part is then P0 for the maximum is going to be proportional to, we've got TC to the power of 5 over MC to the power of 3, which doesn't look correct initially. Yes, I think I've accidentally written down the wrong P0 expression. So if I make sure that I write out the correct P0 expression, so P0 max, we obviously have to take the one that is the original from the paper, not the one that I've accidentally taken, which is the already one where we've taken the derivative with respect to R. For RC max is going to be P0 was going to be a scaling relationship for now. If you remember, P0 was given as K1 MC TC over RC to the power of 3 minus K2 MC to the power of 2 over RC to the power of 4. So I'll now make sure to trace this properly. TC R to the power of 3. We had R given as MC over TC, so if I pop that in here, that'll give us an MC to the power of 3 and a TC to the power of 3. That looks now better. Plus, in this case actually a minus, and we've then got I'm ignoring the constant because we're working as a scaling relationship, we've got MC squared, and all of that was over RC to the power of 4, and that means we've got MC to the power of 4 and a TC to the power of 4. And as we did before, that cancels, this cancels, and this can be taken as T to the 4, and you've got essentially 2 times the same term, and overall I can express this as P0 max is going to be a scaling relationship between TC to the power of 4 over MC to the power of 2. Now, that looks like it's the right one, so always make sure to insert that into the right equation, not like me do the mistake doing the one from the derivative.